Assalamualaikum and hi. In this video, we are going to explain about our case study, which is queuing theory project. We want to know how the waiting lines at the place that we had chose. Firstly, I would like to introduce my group members. Starting with myself, my name is Nur Lydia binti Amil Mahsan. Second, we have Nurin Jaslina binti Nourisam. Third, we have Aliana Bila binti Januddin. And last, we have Maizatul Mardiah binti Saiful Samrud. I will explain the introduction of our case study. We had chose Mary Brown as our place to do this case study. Business type for Mary Brown is fast food franchise and it is located at Jalan Perdagangan 5, Pusat Perdagangan Raup 27600 Raup Pahang. The time operation for this business is from 10 AM to 10 PM. We had do our observation for 3 hours, from 12 PM to 3 PM, and there is only 2 number of the servers at that time.
Next, we proceed with the characteristic of the queuing system. The first characteristic is arrival characteristic. First, size of the calling population is infinite since customers are arriving at the fast food franchise which is Mary Brown. Second, pattern of arrival at the system. The assumption for a customer arriving at the service counter follows the Poisson distribution, which is 21 customers per hour. Thirdly, behavior of the arrivals. There were pension customers that is wait in the queue until they are served with their orders. Some of them are reneging that who entered the queue but then leave without completing their orders. Next, the second characteristic, which is waiting line characteristic. First, the length of the line is unlimited since the counter serves arriving customers who wants to order their food. Second, the queue disciplines is FIFO, which is first in, first out. That is, the first customer order will get their food first and follows the other customers.
Next, we will proceed with the service facility characteristic. For the service facility characteristic, we will look into 2 elements. The first element is the configuration of the service system for Mary Brown in Raup. For the configuration of the service system, there have the number of channels and the number of faces. For the number of channel, or we can refer to it as the server, in the Mary Brown queuing system, for the number of channel is a multi-channel system. In this case, the server is the cashier counters. From our observation, Mary Brown in Raup has 2 counters as their server, where it can be denoted as S equal to 2. Next, the number of faces, or we can refer to it as the station. In Mary Brown queuing system, the number of faces is multi-phase system. There are 2 stations for the customer to receive the services that can be denoted as S equal to 2. The first station is where the customer's order will be taken, and the second station is where the customer receives their order. The second element is the pattern of service time, which refers to the value of Q, and it follows the exponential distribution with the value of 23 customers per hour. Next, the basic queuing system configuration for Mary Brown in Raup is the multi-channel, multi-phase system. How is this work? Basically, the customers will arrive and will be queuing in the waiting line, which is represented by the yellow circle. After that, they will be served by the service facility. Station 1 is the cashier counter. This is where the customer order will be taken as shown in the diagram. Then they will go to the station 2 where they will take their orders. After they completely served by the 2 station, they depart from the Mary Brown. That is how the basic queuing system configuration work in Mary Brown Raup.
I am going to explain on calculations. For our queuing calculations, we will use multiple channel method. First, we need to identify our arrival rate, service rate and number of servers. For our arrival rate, which is lambda, we got 21 customers per hour. As for service rate, our new, we got 23 customers per hour and we have 2 servers. Now let's proceed with the calculations. First, we are going to calculate on the probability that the service facility is being used, or known as rho. The formula is lambda divided by S times with mu. Then we substitute the information in the formula and got the probability of 0.4565. Next, we are going to find out the percent idle time or the probability of no customers in the system, also known as PINAL. To find P null, we have to use the formula as shown. Then, we substitute with the informations that we have and we will got the probability of 0.3731. Next, we want to find out the average number of customers in the queue, or known as LQ. From the formula given, we substitute all the informations into the formula and calculate it. Then, we will got 0.2404 as the final answer. Now, we will find out the average number of customers in the system, which is L. To find L, we have to add LQ with lambda divided by mu. Then, we substitute all the informations in the formula and we will got the answer of 1.1535, which is approximate to 1 customer per hour. Next, we will find the average time customer spends in the system, or find W. To find W, we have to divide L with lambda. Then, we will got the answer of 0.0549 hour, which approximate to 3.294 minutes. Lastly, we want to find out the average time customer spends waiting in the queue. The formula for this is WQ equals to LQ divided by lambda. Then, we substitute the informations in the formula and got the final answer of 0.0114 hour, which approximate to 1 minute.
In conclusion, the number of servers provided is adequate because they can provide immediate service to their customer. Are the customer happy with the waiting time? Yes, because the customer only have to wait 1 minute.